предоставляется Бенджамину Динстону, Институт Ларош. Пожалуйста.
Hello. So my name is Benjamin Deniston. I'm going to be, I'm also with the LaRouche Policy Institute. So I'm going to be following up on what my associate Jason Ross just presented. So what I'm going to focus on is, as Jason discussed, real economic growth is a transcendental qualitative process. And what I'm going to discuss is what types of programs are needed, what types of specific programs are needed to guarantee that type of growth. And so what this becomes a discussion of is economics as a physical science. The science, a physical science of how mankind progresses, grows, increases in productivity. I'm going to highlight this. I will discuss a specific characteristic of that, which LaRouche has identified as energy flux density. And then I will discuss what types of programs we need to ensure that we increase the energy flux density for the benefit of mankind, for both defense and economic progress. So, next slide. If you look at 3,000 years of human population levels, population is constantly increasing for the human species. So what Mr. LaRouche has studied is how do we identify the science that gives mankind this unique capability to expand our population levels, expand our productivity per person, and how do you understand that as a science? Next slide. This is important because no animal species can do this. No simply animal species can grow its population the way humankind can. So what makes mankind unique becomes a subject of scientific study. So next. Now to investigate this, Mr. LaRouche has developed, again, a physical science of economics. And just to give a very brief sense, he looked at what you might call a thermodynamics of human economic processes, where you look at the ratios of productivity relative to consumption. And you look at the ratios for the whole of human society, the entire economy. And you look at the ratios of the increasing productivity per capita, and how throughout human history you've seen that it takes fewer and fewer, that each individual operative of an economy, each individual worker, becomes qualitatively more and more productive. And this is detailed in a number of LaRouche's works, for example, in this textbook on economics. So next slide. No, back one. So this, again, if we look at the growth in human population levels over 3,000 years, we see that two things are the case from the standpoint of this thermodynamics of human economics, which is that you always have a continual increase in the total energy of the human economic system. And you always have an increase, if it's successful economic growth, you have an increase in the free energy of the whole economy. So next slide. Now I'm going to highlight a key, very important metric that correlates with this process. This becomes the study of what LaRouche defined as energy flux density, where if you look at the history of mankind's usage of different power sources, you see that mankind moves from being dependent upon wood, a wood-based system, to a system of coal, to a system of petroleum, to a system of nuclear power, both nuclear fission and nuclear fusion. And you can measure the difference in these different qualitative energy sources in the energy density comparison of the various sources, where you can say an equivalent, to get an equivalent amount of energy out of different fuel sources, to get the same amount of energy out of different fuel sources, you need dramatically different amounts. And what this reflects is as mankind moves to utilize energy sources of higher and higher energy density, that correlates with mankind's dramatic population growth and increase in the productive powers of every person in your society. So next slide. So now to highlight a specific case study in this question, we'll look at the threat of impacts into the Earth. And this can be classified as two main areas of threats. The threats of near-Earth objects impacting the Earth, and a qualitatively different threat, the threat of long-period comets impacting the Earth. So these are two examples of the types of threats that we know that mankind is going to have to deal with at some point in the future. This is not a question of if, it is a question of when. When is this going to happen again? And is mankind going to be prepared to ensure that we don't have damage to the Earth and a major loss of life, and potentially the extinction of human civilization? Can we take the necessary actions to ensure that that doesn't occur? So next slide. So then to take this question of energy flux density, this was cited in the 2009 AIAA report on planetary defense. You can take just a simple comparison of, take asteroids for example, asteroids of different sizes, going from 50 meters, 100 meters, 1 kilometer, 10 kilometers, so asteroids increasing in size, and then compare how early you must affect that asteroid to ensure it doesn't impact the Earth. So how many months or years before an expected impact do you have to affect that asteroid? And what we see here is a very, very clear expression of this energy flux density. It's one expression of a more general principle. But you can see that if we were to utilize solar sails, solar power, just become dependent upon the radiant solar energy of the solar system, that is the least effective method that we can use to protect the Earth from asteroids. If we go to chemical modes, either with a chemically driven kinetic impactor to impact the asteroid with a heavy object, or attaching a thruster, a propulsion system powered by chemical power. If we use either of those two methods, we have an increased efficiency and capability of defending mankind from asteroids. We can deal with larger objects, and we can deal with them more on a shorter time frame. Now, by far, the most efficient method is the peaceful use of thermonuclear explosives. The power density which you get with thermonuclear power gives you a much greater capability to defend mankind. And you can see, you can deal with objects that are much, much larger, and you can do it on a much shorter time frame. So if there was an object that was 1 kilometer heading towards the Earth, with nuclear you could hit it only a few months before its expected impact. With chemical systems, you need to intersected at least 100 years, if not more, in order to have the same effect. So this is an expression of the, you could say, the per capita power that mankind has available to him when we progress to different levels of energy flux density as a mode of economic practice. So next slide. You can also see a second expression of this if we look at the question of specific impulse. How much push do you get per unit weight of fuel at different modes of energy flux density? So you can see that as we move from a chemical mode of propulsion to a nuclear fission mode of propulsion, and then to a thermonuclear mode of propulsion, we have a dramatic increase in the potential power we can apply as a function of different, in this case, thruster systems or propulsion systems. And again, you can see that that is directly associated with increases in the energy density. How much energy per unit mass of the fuel. So next slide. Now, the use of nuclear power for planetary defense, for asteroid or comet defense, is not a new subject. This was studied extensively all the way back to the early 90s, and I think it's worth highlighting some of the work done by the national laboratories inside the United States, demonstrating the increased capability you get with nuclear systems. And this includes thermonuclear peaceful explosives, but also, as was presented yesterday, with nuclear propulsion, you can begin to move beyond simply ballistic trajectories, and you begin to get constant acceleration, and you can dramatically, one, increase the speed at which you can impact a threatening object, and two, you can increase the, you can reduce the time it takes to get to an object if it's coming near. So next slide. So this becomes very, very important, because if, again, the threat of asteroids and comets, it might not come tomorrow, but it certainly will come at some point in the future. And so the question is, will mankind take the advances to ensure that we can protect ourselves? For example, with the threat from near-Earth objects, we need to be able to control this entire region of the solar system. We need to be able to control the region of the solar system stretching from, say, Venus's orbit out to Mars's orbit, and be able to intersect and move any objects that could pose a threat to us. Next slide. The challenge of long-period comets is a second, even more difficult challenge, because they come in faster. They can generally be larger, and they become harder to see because they come from the outskirts of the solar system and you have less warning time. So this is an even more difficult challenge that mankind will have to make serious technological breakthroughs in order to solve this challenge. So next slide. So this brings us to the example of the science driver. And this goes to what my associate Jason was discussing earlier, that if you are pushing the frontiers of science and technology, it doesn't cost you anything. If you make revolutionary breakthroughs that qualitatively transform the potential for the human species to act, you generate the rates of economic growth and progress that pay off any initial investment many times over. But it has to be a program that pushes the frontiers of technology. It has to be a program that moves us to beyond our current limits into completely new domains of power densities and activities. And so one thing our organization has been discussing and presenting is the question of achieving thermonuclear fusion propulsion for space travel and engaging in international cooperation in the science driver to develop these technologies to advance mankind's complete potential in space. So next slide. So that's what we are, one thing we are organizing for in the United States is pushing this frontiers into this thermonuclear platform. And to end, I would like to step back and highlight and look back on what does this actually mean for the human species. Now, as was discussed at the beginning, no animal species can increase its population the way mankind can increase its population. This means that mankind has a capability that's not a simply biological capability. Mankind has a certain unique power of mind, of creative thought, that gives mankind a unique capability to expand its power and presence in the universe. And I think this was highlighted with the recent landing of the Curiosity rover on Mars. Because now you have mankind, we're not physically there, our biologies are not there, but we are creating instrumentations that we can control with our mind to begin to control this region of the solar system. We're seeing the expansion of the power of the human mind, something Vladimir Vernadsky, with his study of the noosphere. That the way mankind advances is expanding the sphere of control of the human mind to increase mankind's power in and over the universe. So next slide. So that's the objective, very briefly, for what our organization inside the United States is involved in. We're trying to get the United States to take up the challenge of new science driver programs that'll force the breakthrough in new technologies with a heavy focus on nuclear fission, but thermonuclear fusion, as the types of advances that will completely transform mankind's ability to defend himself and mankind's productivity and wealth for all of society. And that's my presentation.